is equal to 0, or M and Mx is equal to 0. Now, the thing now is this, okay? Why this direction? Why shear force is equal downwards and moment at point A is equal to anticlockwise? Anyone, can you all remember? Can anyone remember why that is so? Those of you who are in college before, okay, or who are working now in industry, why do we make that assumption? Anyone, please? Anyone? Can you all recall? I don't see any answer at all. Okay, so probably I would boldly say this: you have seen it before, you have forgotten. Okay, you have seen it before, you have forgotten, or the prof, when you are doing your education, just say just apply this way and move on. Okay, right? Why is it? Because we assume, assumption made, is known as positive shear and positive moment or positive bending moment notation. Okay, so I underline the word. What do we mean by notation over here? We mean by notation over here is we fix a set of rules so that it will also be satisfactory when we or it will also be satisfactory when we apply when we plot into the shear force and bending moment diagrams. So what do I mean by notation again? If I'm going to explain in a simple way, 0 is always at the zero is always where we start from. Positive is always greater than 0, so it's +1, +2, +3, +4, +5. Negative means -1, -2, -3, -1, -5. So that is a notation that we accept. Yes or no? This is like in elementary school, right? You ask me why, also I don't know why. Okay, but it's a notation that have been taught. Okay, someone set these rules. Okay, and based on positive, it always is a plus. Negative is always a minus. And sometimes it's good to be in the minus, not in the plus. Okay, depend on what we do. Okay, so now so what do I mean by positive shear and positive bending moment notation? Okay, so we're going to analyze the beam two ways. Okay, so the first way we're going to analyze, so I'm going to divide this into two. Okay, then you understand what I mean. Now this part is where I'm jumping out from the example and explaining the theory to you. Okay, I'm jumping out from the example, right, and explaining the theory to you. I don't know, is it a better approach? I think it is, rather than tell you all the theory and then do an example, then why is this like that? Okay, so I rather do this in between. So now, if we analyze the structure, from left to right, okay. So what do I mean by left to right? Okay, so this is our structure, right? So this is where our datum is. So this is X, right? This is X, and this is left to right. So down here, you know that it's left to right. So in positive shear and positive bending moment, V is always going this direction. Okay. M is always going this direction. And the moment, okay, is about this point. So moment taken about this point. Okay, so the moment is not taken at the datum. Okay, so now if we want to analyze our structure from right to left, okay, so we're going to analyze structure from right to left. Right, from right to left. So again, datum did not change. Right, but now our structure is over here now. Okay, and I draw the dotted line. The structures you start from the datum. Okay, and then the distance from here to here is x, and the distance from here to here is L. Now, can someone tell me what is the distance from here to here, please? Anyone?
L minus x.
L minus x? Can it be x minus L? Hello?
Then it's gonna be the negative.
Yeah, so negative is wrong, yes or no? So it always have to be L minus x because this term over here always have to be positive, right? So now the analysis go from where? Right to left. So this, I'll draw this. This is our analysis direction. In case some of you are a bit confused. And this is our analysis direction. So when that's the case, when you do from right to left, right, your positive shear will be in this direction, and your positive bending moment will be in this direction. Okay, so you are taking your moment at that point. Okay, so moment taken from here. Okay, so that is what we mean by positive shear and positive bending moment. Okay, so now another thing that yeah, I'll go for this now. Okay, I like to mention is hold on, is this. So this is our beam, right? So this is our beam. Okay, so based on our beam, let me put this in. Yeah, so this is our beam now. I'll try to align the beam such a way that. Okay, so this is our beam. So based on what we see over here, how the beam will deflect, it will deflect this way. Okay, it will deform, not, yeah, it will deform or deflect. Okay, it will deform this way. Okay, so it'll be set face coming down, set face, and then at certain stage you'll go back up in happy face. Again, this is just a sketch. I repeat again, this is just a sketch. So this is the deformation pattern. Okay, so why is this important? Okay, why is this important? So if you look at, if I'm going to draw, okay, if I'm going to draw the bending moment, this is just a sketch, by the way. Okay. Okay. So what do I? So this is our bending moment. Okay. So bending moment can be positive. Bending moment can be negative, right? But what does it actually mean to be positive bending moment and negative bending moment? Anyone, please. What does it actually mean?
The beam is going clockwise or anti-clockwise.
There is nothing to do with clockwise or anti-clockwise relating from deformation to bending moment. Okay, so what does positive bending actually mean?
Positive means beam is bending downwards, and negative means it's bending upward.
Yes, you are partly right. Okay, so on this diagram, okay, now this is based on deformation. Okay, when we have a deformation in a smiling face, deformation, yeah, deformation pattern. Okay, when we have a deformation that is a smiling face, is also known as positive moment. And then we have a moment that is what? That is negative, right? The magnitude has to be below. So this is negative. So this notation over here, right? This notation over here is for your deformation. So when your deformation is smiling, right? The moment is okay. The moment is positive. When your deformation pattern, okay, I'll write down pattern, right? So for this case, right? For this case, if this is my point B, right? I want to do the rest, okay? We will look at point B first, okay? So point B, if we look at the deformation pattern, right? We already know that point A, we're going to start from 0, yes or no? So point B, is it going to be positive moment or negative moment? Anyone?
Negative moment.
Yeah, it's good. We're going to see negative moment. Okay, so we know negative can be this way or this way, either one. We don't know yet, but we know that it's going to be negative. Okay, now then at approximately a certain distance away, right? Approximately a certain distance away, at this distance away, right? So at this point, is it smiling face or sad face? Anyone? Is
Yes,
it smiling? Hey, you
Is
can't
that
say
face?
you can't say that because on the left hand side is a part of the set, and the right hand side is part of a what? Smiling. Yes or no? Right? Hello? Right? Makes sense, right? So when that's the case, neither is it smiling or sad face means at a certain point is going to be what? 0. Again, this is just a sketch. Okay. Then between this point to up to point C, is this smiling face or sad face? Smiling face, right? Right? So that's where it will be going up and then coming down this way. Okay. Or yeah, this is the only way. There's no way that you can get I'm thinking about the other direction. Okay, there's no way that you can get this and this. Okay, that is impossible. Okay, but you can get up to the peak and a straight line. It can be a straight line or curve, but not curve in this direction. Okay, so that is what we mean by understanding the deformation pattern and relating by moment. Okay, so for this case, you can already relate with what? Later on, I'll teach you how to relate with deflection. Okay, later on. Okay, but I'm building a trend so y'all can visualize this. Okay, right. So now the next one, we're going to apply this concept. Okay, we're going to apply left to right. Okay, because this you can't see left to right. Yes or no? It's 0, Eugene. What left to right? I see nothing. Right. Okay, so we are going to do. All right, so we're gonna go from A to B.
Sorry, Eugene, can you just show that graph at the bottom for just a few more seconds?
Yep.
Thank you.